Okay, people, welcome back. We are going to have a few questions involving the strongest force in the universe, the strong nuclear force. It is a force that we will be using in our future to go to the stars, probably a couple hundred years from now, and definitely already trying to use companies and researchers are close to be able to use it as a source of energy and electricity. Probably another 10 years or so, they will be using this massive force to create clean energy, kind of clean anyway. They need a lot of energy to produce it, actually. Okay, so that's that. A little bit of an intro there. You will have about eight questions. Some are multiple choice, so it shouldn't be too bad. You're going to look at a video. Okay, and I'm just have my little notes here. Okay, so we've been looking at the strong nuclear force. Okay, it is so massive and so strong. Even though it only works at the atomic level, very tiny level is only when it works. Less than the size of an atom. Or the size of an atom or less. Okay, so but the force is so strong that if you were able to make a nucleus the size of a city block, where do I have this? If you were able to make a nucleus the size of a city block, then the strong nuclear force would have enough force to reach farther than the distance across the United States to keep electrons, which would also be bigger, a little bit, probably the size of a baseball or something, keep it from going away. That's how powerful and large this force can be. But it operates at atomic or subatomic level. It is the strongest force we know of in the universe. And it's very difficult for us to even study it yet. Though we know how it acts a bit, but so we could use it, but we don't know really much about it other than what it does. Okay, so there's a few notes. We had these before, and it works across relatively empty space, a big amount of relatively empty space. And if we remove the space inside atoms, the density of such an object would be amazingly heavy, incredibly dense. And one of the objects known for that, for having very little of this atomic space or no atomic space, are neutron stars. So we have an actual object in the universe that can tell us a little bit about the strong nuclear force working across space and removing space inside atoms. Okay, how do we remove that space? An incredible amount of gravity squeezing, which all these, we're talking about forces at levels we can't even imagine, actually. Okay, so we're going to look at the video and then we're going to answer these questions. They pretty much go in order from the video, except the last question, which you have to go back to 1 minute 9 seconds of the video to see this answer. Okay, some are multiple choice and some are give a text answer. So let's go to the video, shall we? So they're showing here if there was no space between inside the atoms. So the space from the nucleus out to the edge of the atom, which is mostly, it's all empty space basically. But if you remove that with an unbelievable amount of gravity, it would have the density of a star, many times more than our sun, in the size of a city block. Very good set of videos. So one of our questions, a balance So that's gravity pulling inwards. And then energy, you have those two, you have these hydrogen atoms touching, and they release a crazy amount of energy. That's from the strong nuclear force, and that pushes outward. It's kind of explosive. So we have a balance between this explosive outward force from the strong nuclear force and gravity pulling in. And this process eventually ends. So that's one thing that can happen. But another thing that can happen is when you have a massive star, much bigger than our sun. So when the process stops of hydrogen, when the process stops on a massive star, then you actually, gravity starts again, and you get bigger molecules, bigger elements. I tried to stop the video, but I couldn't. Then that second, what is going on? Then that second process stops, and then you get a supernova. And in that supernova, huge elements and atoms like gold are produced. So the gold we have, and a lot of our bigger, like lead, they're produced in supernovas of giant stars. Here comes a supernova. So that was a giant star. So here we go. We have gravity so great. Gravity becomes so great that it actually squeezes the empty space out of atoms out, which is unbelievable. So there goes the space between inside the atoms from gravity. There they'd be making a nebula, actually. And the explosion is a supernova. And then you get a neutron star. And that is where we're ending this video. You can see. So you have a space, a neutron star. You have a space the size of a city, or Pinellas, actually smaller than Pinellas County, with the mass of a giant star. So that is pretty much beyond anything we can even imagine. Okay, so that is the review. I think, come on now, stop. It will not stop. There we go. You stop. Okay. And go back to, oh, go back. So here's the assignment. Hopefully that makes it reasonably, make it so you can find the answers. And if you have any questions, right, go on Teams and ask them. Okay, that is it, people.